Okay, welcome back. And let's proceed to the second formula, second method. That's the Crammer's rule. So Crammer's rule. Let's do that. We'll be taking the same example we solved using matrix inversion, and that example is 2x1 plus 3x2 minus x3 equals 4. 3x1 plus 2x2 plus x3 equals 5. x1 plus 3x2 plus 2x3 equals 6. So this is the question. So what is Crammer's rule? What Crammer was trying to do is just for us not to go through the stress of calculating inverse, cofactor, transpose, determinant. We'll be using determinant though, and the likes. So if we have this way of solving now, let's make this our matrix as usual. Remember ax is still equals to b, so let's make this our matrix. A equals 2, these 2, 3 and minus 1. Then we have 3, 2 and 1, so we have 1, 3 and 2. And our b equals 4, 5 and 6. Okay, so now our x is still our x1, x2, x3, they are still unknown values. Now let's solve. For us to get x1 in this case, now what you have to do is to calculate the determinant, this determinant of ax1. Please note, determinant of ax1 divided by determinant of a. And for us to get x2, we do determinant of ax2 divided by determinant of a, and x3 will be determinant of ax3 divided by determinant of a. Okay, good, very simple. So once you do this, you get the answer. Now let's get the determinant of ax1. How do you do determinant of ax1? We don't have the matrix of ax1, so how do we do the determinant of ax1? This is how you get the matrix for ax1. Your b solution, we remove it from here, and this is the column for x1. As you can see, x1, 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 this is the column for x1. So we remove all the x1 here and put the b there. Remove all the x1 and put the solutions there. So our new matrix will be the matrix of ax1 will be equal to 2 we leave and 4 will substitute it, so we have 4. 3 we leave this place and 5 will be the new one. 1 will leave and 6 will be the new one. So it means you remove this column and you replace it by the solution. So you have 4, 5, 6, 3, 2, 3, minus 1, 1 and 2. The only thing that changes from here is that the column for x1 is no more there, but we are replacing it by the solution. Now let's find the determinant of this. Remember your formula for determinant. We have plus 4 multiplied by, you close this, you have this left, 2, 1, 3, 2. Minus times 3, minus 3. You close this column, close this, you have 5, 1, 6, 2, plus minus 1 of, if you close this and close this, you have 5 2 6 3. So these are determinants. Now let's proceed. So we have plus 4 of 2 times 2, that's 4, minus 3 times 1, that's 3, minus 3 of 5 times 2, 10, minus 6 times 1, 6, plus minus 1 of 5 times 3, 15, minus 6 times 2, that's 12. Just follow me. So we have 4 times 1, that's 4 still. This will give us 10 minus 6 is 4. 4 times minus 3, that's minus 12. So this will give us minus 1 times 3, that's minus 3. Minus 3 times plus, that will still be minus 3. So what you have here will be 4 minus 12 minus 3. And that will be 4 minus 15, which is equals to minus 11. We've gotten the determinant of AX1. So what's the determinant of A itself? If you follow the last matrix inversion class, you will realize that we got the determinant of this A to be equals to minus 20. Well, let's just solve it. Determinant of this A will be, I will go as fast as I can. Determinant of A will be equals to 2 of 4 minus 3 minus 3 of 6 minus 1 plus times minus, that's a minus 1, minus 1 of 9 minus 2. So the determinant of A will be equals to 2 minus 15 plus minus 7. That will be 2 minus 22, and that's minus 20. So watch out, the value of x1 will be equals to minus 11, that's the determinant of AX1, divided by minus 20, which is the determinant of A. So your answer will be equal to 11 over 20. Let's get the value of x2. AX2 will be equals to 2, 3, 1, 4, 5, 6, and minus 1, 1, and 2. So calculating the determinant of this, we will have 2 of determinant of AX2 will be equals to 2 of 5 times 2, 10, minus 6 times 1, 6, plus minus plus, minus 4 of 3 times 2, 6, minus 1 times 1, that's 1, plus times minus 1, that's the minus 1 of 3 times 6, 18, minus 5. So we have 2 of 4, minus 4 of 5, minus 1 of 13. So we have 8 minus 20 minus 13, which is equals to 8 minus 33. This will give us minus 25. Our x2 is now equal to, remember the formula, determinant of AX2 divided by determinant of A itself. So we have minus 25 divided by minus 20, which is equals to 5 divided by 4. This is actually easier and faster than matrix inversion. So for us to get the value of x3, we'll do AX3 divided by A. Determinant of AX3 divided by determinant of A. We've spoken about that already. So what is our AX3 now? I want everybody watching this to pause the video and draw the AX3 yourself, just as you have explained. So if you do that, you have 2, 3, 1, 3, 2, 3, and then the last column of A, you substitute it for the solution. So you have 4, 5, and 6. So I'll close this. Now let's get the determinant for this as well. So you have 2 of closest 2 times 6, that's 12, minus 3 times 5, that's 15, plus minus 3 of 3 times 6, 18, minus 1 times 5, 5. Lastly, plus 4 of 3 times 3, 9, minus 2 times 1, that's 2. So we have 2 of minus 3, minus 3 of 12, sorry, of 13, plus 4 of 7. So our answer will be minus 6, minus 39, plus 28. And this will be equal to minus 45 plus 28. This will give us 17, I guess. 17. Sorry, minus 17. Okay. So we have minus 17 divided by minus 20. Our answer will be 17 over 20. So our x1 equals 11 over 20. X2 equals 5 over 4, and x3 equals 17 over 20. And that is it. Remember, the answer is the same thing as the answer we got for our matrix inversion. See the same solution, 11 over 20, 5 over 4, and 17 over 20. That's a proof that our solution is 101% correct. So we have this. X1 is 11 over 20, 5 over 4, 17 over 20. X equals to 11 over 20, 5 over 4, 17 over 20. Thank you.